record. Right, Chimboita, mute your mics so that we don't pick the background, please. Right, let me share again. I was explaining right, I was explaining and adjusting here. We are now saying instead of using this order or the rank, yeah, okay, let's say the rank or order, right? So let's create another column at not FC in a cumulative probability. So this is 7, 8, say as right, 1, 3, 4, 5, 6, 7, 8, 9. Okay, 9 and 10. So our n is the sample size and not this. So we are saying here, we are saying cumulative probability, cumulative frequency minus half for continuity correction. Otherwise, I go to cumulative probability direct, which is p of x less or equal to x. What you observe, number of values less than the value, less or equal to the value over n. Hello?
Hi.
Right, may we mute our mics, please? Right, so this is how you get this column. And then I'm saying here you find the quantiles or the z-scores that correspond to these values. Right, let's make sure we mute our mics, please. Right, Mnashe, may you mute your mic? Right, so we are saying to find these values, kana uchishandisa your statistical tables, ramunoshandisa muexam, unoenda mukati, the values, you get the probabilities mukati. What you get to left hand side, z values. Aya tinowash, you use that left when we want to find this probability. But now we have this probability and we want to find the z value. Saka tinotarisa mukati, you get the probabilities. If you look at the values dziri mukati mechitable muya muya, they are the ones that range from 0.00003 kusvika kuna 0.99998. Saka these are probabilities. But also one way of finding these for assignments and things like that, you can use Excel. Right, I'm not sure, can I show my Excel? Right, can you see my Excel? Am I sharing Excel there?
No.
No.
Not visible yet.
Okay, okay. Right, okay. I think. Makuyona. Excel.
Yes.
Okay. So with Excel, if you look panapa, ndikaenda musel iri, ndambofanoita. The function yatinoshandisa is n normal inverse. Right, where do you get this? Ukati equal to, and then you click on this function there, you can get all my values, my functions are statistical. You have the whole list, yokutsvaga even my probabilities from a t distribution. Most of the distributions are covered. F iripo, exponential iripo, gamma iripo, and normal. So I'm using here normal, right? Which is the n inverse. This one, yakanzi n distribution, inde kutsvaga the you have your X, you want to find the cumulative probability. So this is for finding the cumulative probability. But now, because in a cumulative probability, to know the value whose cumulative probability is the variation. So that's what we mean by z scores, quantiles. Tine a value, tine a probability. We want to find the values whose cumulative probability is that. Do I not my quantiles count my z scores? So if you go panapa, right, and click, right, my parameters that is the probability, the cumulative probability actually. So in this case, ndoda kuwa na 0.05. That's the cumulative probability and ruled out chunk. I'm using the standard normal. So the mean for the standard normal is 0. I'm using the standard deviation is 1. So if I do that, I get chi minus 1.645. So I can just pick one value, one more value from our table to illustrate how you get these using the Excel, how you use Excel. Right, let me see. Right, so let's pick one value. Right, let's say true a value whose cumulative probability is 0.65. 0.65. So panapa, instead, adjust. Ndaisa 0.65 there. Doti 0.385. So I can maybe, to make it easy, I can write my values, my probabilities. The good part you can answer Excel 0.05. Oh, I'm not sharing. Right. Right. Let me just, I will share with you Excel Canada page. Let me just copy my values and to Excel. Tongo Aitaka 1. 0.05. The next one was 0.253555. 0. No, I will share with you Excel Dapeza 0.35, 0.55, 0.65, I guess. 65. So it's 0.05253555 657585 65 0.75 0.85 0.95. Right. Let me share with you this page. Excel. Right. So we are saying to get the cumulative the z values, we are saying is equal to normal inverse, right, for the value, the probability. I'm now using, let me just use the value there. 35, is it 35? Okay, here. So it's 0 n inverse, n normal inverse, which is this, of the value. Okay, and then the mean is 0. The standard deviation is 1. Right, so it's 1 point. So I just want to auto copy. So those are the values. Right, am I sharing Excel with you? Hello?
Yes.
Okay.
Yes.
So those are the values that we expect to be, these are our QIs. So we are saying you plot this against 3, you plot this against the next value, which is 5, you plot this against the next value, which is 6, you plot this against the 7, you plot this against 8, against 9, against 10, against, but against the values that correspond. So that's how you find my values. But if you are using your statistical tables, it should be Right, can I through contributor? Let's mute our mics, please. So that's it for the QQ plot. Okay, that's it for the QQ plot. Shall we proceed to the next question?
Yes, ma'am.
Okay. Right, Anne. Okay, here. Right, so now we want to look at how you perform the chi-square. Basically, my principles are the same. The principles are the same for doing the QQ plot and the chi plots. The only difference is how you get my values, my quantiles are tighter. So if you look at the procedure here, chi-square plot, we first have to compute my DI squared. Right, so let me move on to the next page. Right, at our chi-square plots. Aseka handwriting. Right, chi-square plots. So the procedure per outline and the first thing is to compute your standardized distances of each xi, and we get it by di squared, mass squared distances. We call them mass squared distances. This time at satita order, tatikana indexing each na I is just the value that I observe in this position. So this is equal to xi, the observation vector, read that in the individual, minus x bar transpose onto S inverse, the inverse matrix of in the S matrix, as soon as but in the S. Maybe let me erase and try again. Inverse matrix, yeah, the sample variance or variance matrix, right? I think we are none onto X I transpose minus X bar. Right. So in this case, which means if we look at our data, panapa, right? You can come with calculator DI squared for each observation. Takakana chiti x1 like that, the vector, observation vector is this one, right? So what you need here, you need to have calculated x bar. Right. In this case, say my x bar is, this is, I'm using, and now calculate, and this panaka calculator x bar for this matrix. Aripoe. Panaka calculator x bar for this data matrix. Amusudaira. Daira maka calculator area, otherwise I will just use some values, because the challenge here, so when someone follow not tataura kuti we are supposing, but now let's have the values kana pane akacalculate. Kana Mnashe? Pane vanhu here apa ndingoona Ted. The other guys, where are you?
We haven't calculated, ma'am.
All right. So let's assume, all right, kana akacalculate here. Kana pasina for progress sake, let's assume kuti ndi 6 na say 0.9. Ndikuassume kuti ndiyo x bar e. Right, let's assume kuti S inverse. Trukuda S inverse.
6.1 and 0.88.
Ichi
6.1 and 0.88.
All right, thank you. 6.1 and 0.88. All right, ngatingoyuza 0.9. Thank you. And then you need S inverse. Right, tikatarisa ku formula kwedu, we need S inverse. Right, x bar naye my xi vectors now. So we need S inverse, which means you need to calculate the sample standard deviation, the sample variance covariance matrix. So then you find the inverse of that 2 by 2. It should be easy. It's a 2 by 2 matrix. So say Dawana inverse, it is 0 for simplicity, no, it is 0.1, 0.2, minus 0.3. Say that's the, so which means pana patina minus 0.3. Toti ndio inverse matrix here. So which means uchauya for this value, you calculate di squared as 3 minus 6.1, 2.3 minus 0.9. So that's your vector x minus x bar. You as a raw vector transposed times this matrix times the same difference yatataura. So you do that for all the values. One my di's. Saka say my di's angu item. In this case, my di squared. You expect this to be, these are squares. Saka panachiri negative. Say I'm just giving my value 0.5, 0.3, 0.1, 0.3, 1, kashoma kuti azofanana, and so on. So one my di squared values ako. Then the next step is to order these values. You order them. Saka procedure yafanana like we did for this question yekutanga, right? So you now order. Saka can we mute our mics, please? Right, pakuita as if urukutanga nema values akaita se aya. Saka instead tana ma di squared pana di squared, my squared distances rather than my xi. Then you order them, my frequencies, but in this case you don't anticipate any one value in a rematide observation. So maybe it will be my 1, 1, 1, 1, and then you find these probabilities, my cumulative probabilities, my di's I. Now we are working with my di's. So you find these cumulative probabilities, and then we end up with chi-square. Now instead of using the normal, we are now using the chi-square distribution. right? Chi-square distribution inenge ine degrees of freedom are equal to the number p, right? So you are using a chi-square distribution in a p, where p is the number of my degrees of freedom edu. It's equal to p, which is the number of variables. Saka x vector yedu is a p by what? So p, when in this case, ndio inotipa ma degrees of freedom a chi-square. Saka you now find ma quantiles. Atingati ma z values zvekuningi. They are quantiles. They no correspond to my cumulative probabilities ema dii. Ata calculate chiti cumulative probability, cumulative frequency minus half over n, and so on. And then you find my quantiles, a chi-square distribution in a 2 degrees of freedom. You plot my di zako versus my quantiles. So that's the chi-square plot. That's the narration yaninga papa chi-square plot. It would take time to teach my chi-square plots, but maybe what I can do, and you can work, and then I will share more like a solution for this question through a PDF document. But in terms of the procedure and the outline, that's how you perform my QQ plots, nema chi-square plots. And mu exam irimo question inoda izvozvo. Any questions? But it's amongst my options that you can decide not to worry yourselves nayo, but what you maybe zvamusingazozivi kuti inenge yakabatana which other question iri maybe which may be easy. So zvairi kusection B, I'm not sure section B or section A, maybe ndakutaurisa zvakawanda, but there is a question. Any questions on the procedure? QQ plot, chi-square plot. Karapasina, let's move on to the next aspect and no doubt to discuss. Right. Question A3. Question A3, you are given a summary statistics, the summary statistics for a bivariate normal distribution with sample size 14, and you are given the mean vector and the variance covariance matrix, sample, mean vector, sample, variance covariance.
Yeah. No.
Right, so I'll mute you all for now so that we don't get more disturbances. So the first thing is to find the eigenvalues, eigenvector pairs of S, right? If you look at this matrix, it's a 2 by 2 matrix. Finding the eigenvalue, eigenvector pairs of S should not be a problem. But maybe what you should take care of, especially when you, or take note, when you find my eigenvalues, eigenvector pairs, just to check, because when we define my eigenvalues and eigenvectors, we want them, the eigenvectors, to be orthogonal. So like in the example, yatakaita ma notes, yanga iri a 2 by 2 matrix, takaita ma eigenvalues and ma eigenvectors aunowana direct, even ukanormalize, they are not orthogonal. So in that case, when you check your orthogonality, kuti ari perpendicular, if wawana asiri perpendicular, you won't report zvinhu zviri perpendicular to be your eigenvectors. You would then need to use the Gram-Schmidt process to convert or to find my perpendicular vectors or my orthogonal vectors. Maybe that's one point I'm going to point on finding my eigenvectors. So you check with my eigenvectors, are they orthogonal by finding their inner product? E1 transpose by E2 should give you 0. Then you know they are perpendicular, they are orthogonal. So that's the point. Yet no panap. Now going to part B here. You know, to construct and sketch a 95% confidence ellipse for the population mean vector. Construct and sketch a 95% confidence ellipse for the population mean vector. If you look at the 95% confidence ellipse, takati iri, do I have the notes? Again, meeting yakuda kukatwa in 10 minutes, 40 minutes dzakulapsa. So expect a disruption there. So what you need are the eigenvalues and eigenvectors of S, or indirectly, but it's a hasu kudilana S inverse. So you are better off working with the eigenvalues, eigenvectors of S. And then we know the relationship between the eigenvalues of S and S inverse. We know the relationship between the eigenvalues of S and S to the half, that is the square root matrix. You know the relationship between the eigenvalues of S and S to the minus half, right? The eigenvalues of S, if they are, it depends on what you do, how you define this. Kana ukada direct kutraga S inverse and then you get your eigenvalues or eigenvectors, then it's something else. But usually the standard way is to find the eigenvalues and eigenvectors of S. Sando atisha refer to as lambda na E. These are relating to S, which means if I want, because on our formula one at the 95% confidence ellipse, tinoda S inverse, the formula haina kunyanya kusiyana ne what we have been using to find my squared distances. We are dealing around that quadratic form, this one. This quadratic form, right? We are dealing around this quadratic form. I think even pamushaenda mukano tarisa kana taku discuss or maerenga, they were telling T squared inodila futi around this quadratic form ya S. Saka hapana patichashandisa SRS. The matrix yatinoda, the center matrix yedu the quadratic form is S inverse. Therefore, the link between the eigenvalues of S and the eigenvalues of S inverse in the so if you define your lambda to be the eigenvalue of S and E to be the eigenvector of E, which means the eigenvalue of S inverse, no, 1 over lambda, and also my eigenvectors, they are the same. Panapa tinenge takutaura na square root of lambda, is the eigenvalues, and the eigenvectors are the same. So that being the case, you now go to the formula yatakati yokutsvaga the confidence ellipse, right? The formula for finding the confidence ellipse, right? Let me try to find that. Right, we have X x minus, so it's x bar minus mu, right? So I will refer to this thing shortly. X bar minus mu s over n inverse onto, there is a transpose there, x bar minus mu, right? So patachita ma di, I want to bring the difference because this difference confuse most people. Patachita ma squared distances. Tachita pakadai. The I1 rule unyora minus x bar, right? So I want to point out the structure of these things, my quadratic forms, but what you have to take note, chinotisianisa, variance ya xi, the s, right? Mean yema xi is the x bar, right? Then kanataka kudila nema means, and it is kuti confidence ellipse for the population mean. Population mean yedu nde. Isusu what we know is this simple. So we make inference around population mean tichishandisa the sample statistic. Even patichaenda panapa patino tested this hypothesis. Tinoshandisa x bar, tinoshandisa the telling t squared, inenge ine more or less the same structure. Saka msiyano uri kuuya panapa kana tikatarisa ma x bar, I think pa proof yatakaita previously takashowa kuti x bar expectation yayo ndi mu, covariance ya x bar ndi sigma over n, ndo pari kuuya sigma over n panapa. Saka ndo difference iripo pama toati ma quadratic forms are 2i, but anoshanda zvinoda kufanana. Saka people vanoita confusion kuti when do I use s over n. Saka panapa tiri kuti s to the minus 1, this is 1 over n to the minus 1, so this is more like 1 over n, 1 over 1 over n. Saka you are dividing by a fraction 1 over n. Saka at times n uyu tinogona kumuwana asisiri panapa, tinogona kuchiwana chakuuya chiri kunoku apa pakangonzi s to the minus 1, pakungonzi s to the minus 1 because tatina 1 over n tichimuraiza to the power of minus 1, which is more like 1 over n, 1 over 1 over n. Saka when you divide by a fraction, you multiply, you invert and multiply. Saka inoto kudaya n. Saka you would find panapa tinoda kushandisa this form. It's easier to use it in this form. Pama di's ndo patinoshandisa this form, but pama questions aya 2i anoshandisa this form and tinenge tichidhilana x bar hatisi kuzodzoka. If you look at this question, hapana paushawana ma xi, tina x bar, right? So that's the thing. So we want to find, I think maybe for a session yatichaita later kuti tipedzise time haichandibvumiri. I've strained myself. What I can ask you to do is moita question yepamusoro iyaya, moita this question, motsvaga ma eigenvalues, eigenvectors acho as kana as inverse, so that when we come panapa takuskecha it would make sense. I think again the same things zvatashandisa apa ndozvatichashandisa for ma Benforroni nema simultaneous confidence intervals. Tobva complete this thing in the next session. So I will record this next session. If I come tomorrow, almost the same time, vanokwanisa you can join, but I think I will record the session and then ndichipedzisa this thing with my worked example so that we won't take much of the time, and the other aspects zandoda kukava nongosvikava zvese. That is if I'm feeling well tomorrow, I will pick it from panapa. But vanokwanisa tsvagai ma-eigenvalues, eigenvectors of this matrix so that we can be able to answer this question. Ndokuratidza kuti ellipse yacho takuiplota sei, where is the center, how do we handle this? Then kutesta this thing won't be a problem. Kana moment tatongokwanisa kushandisa this thing, it uses the test statistic inenge almost in this format. Any questions? Pasara 1 minute, any time will be cut off. Any questions? Muchiripo ere? Yes, right, let me